Do you have the best machine learning model? Do you know how to form newly generated Pokemon out of thin air using generative adversarial networks? Or have you cracked the secret to autonomous driving without using frontal LiDAR? Or did you even pass the Turing test, training a language model on billions of parameters? Today I will make a video for you. I'll show you how to build a machine learning API using FastAPI and Docker. So let's get started. To build our API today, we'll have to do several steps. First, we'll have to actually train our model and of course install the dependencies. Then we'll have to build our API. Then we have to test our implementation, and then we'll make a Docker container because it's so much easier in practice. If you don't know any of them, I'll now go through step by step, explain you the basics. So basically, to get started, what you want to do is pull my GitHub repository here, git clone. So assuming you have Git installed and you have Python installed. If you have Anaconda, that's even better. If not, don't worry too much about the Conda things. It should work with any Python version. I'll point out where you may get errors if you're not using Python 3.7. Probably not. It's just for those 10% that may run into an error. Anyway, to install these things, either do Conda, create something Python 7, clone my Git repository, and once you've done that, cd to the tutorial machine learning API. So where is the repository? It is here. So I uploaded this. This link will be in the description or in the comment section. Check it down below. I already did this for you. I pulled this repository and we are in here. So as we can see, it has several files and a README. The README should highlight all the commands you will need in case you want to copy paste them instead of typing them off a YouTube screen. Just here for the tutorial. How will we be doing our API today? A machine learning API is quite a lot like all other APIs. So this is also a great tutorial for APIs, but I wanted to highlight the entire stacks and some design decisions that you have to make just to get a simple API running. There are a few more things that you may want to consider if you're really doing this in production with a large team. But I made it as short and simple as possible while still giving you all the tools you will need to do this. We'll be using sklearn. So sklearn is a machine learning framework that features all the popular machine learning algorithms that you could possibly want. We'll mostly be working with decision trees for today, but you can also work with TensorFlow or PyTorch. Once you got this tutorial running, you can then easily replace the model with anything else and it should work just as easily. We first build our API. What are we using today? We'll be using FastAPI as it said in the title. We'll be using FastAPI today as I mentioned in the title. Just to highlight why we'll be using FastAPI, you can also use other APIs in general, but I think FastAPI is really doing a great job as also 27k stars on GitHub show. It's really simple, it has minimal overhead, it is quite efficient, and it integrates very well with Python, which is probably the most popular machine learning language anyway. Just to highlight shortly why I think it's a great tool. I'm using FastAPI a ton these days. I'm actually planning to use it for all my team's machine learning services at Microsoft. So this is by Kabir Khan, and he surely knows what he's talking about. So also big companies definitely use this. It's great. Once we've done this, what you really want to do is test your implementation. Imagine that like 3 months from now, you want to update your model or you do some hyperparameter changes to it. If you somehow switch the version or something and your Docker container may not have already gotten the right version, it may fail in production. This is something you really don't want to have. This is exactly why I'll shortly show you how to test. It will not get too deep into it, just a few minutes, just to highlight that it's useful. To those of you that do not know what Docker is, or also a little recap, Docker is basically a bit of a program that helps you containerize applications. What is an application? Application is, for example, a server like the one we're building today. You'll have a computer usually, and inside this computer you have resources. So you have a CPU, you have some memory, you have hard disk, and you can separate these resources into, you can run several Docker containers or apps on one server. To make sure that the different versions and the deployment processes for all of these apps are somewhat independent and that the cloud providers can easily manage them for you, Docker is a great middle point between your operating system and your application. If you know Docker already, you know this is a bit of a simplified explanation. If you haven't used it yet, we'll get into your first test with Docker. Don't worry too much about it. All you have to remember, it's the best way to take your implementation and put it into the cloud. It's very well supported also with cloud providers such as not just Microsoft Azure, but also AWS, and also Google has like a lot you can do with them. So no matter what you're doing, pretty much if you're containerizing your applications, this is very good. This means we got everything. Once you got this containerized application and your Docker file, you can easily deploy to the cloud. We will not be doing this today because it depends what cloud provider you want to use. Once you got the container, it should be relatively easy, and there are a lot of videos from the cloud providers themselves that they keep up to date in case anything changes, so I will not be doing this last step. You know now all the things that we'll be doing. We'll be working with the Titanic dataset, so I already stored this here in the repository for you. What is the Titanic dataset? It basically has a lot of features, and the label is whether the person survived or it didn't survive. We'll only work with a subset of these features because we're caring not so much about building a great machine learning tool today, and more about how would you get some machine learning tool to the customer out there. How can you actually deploy and run your predictions once you've trained your model? Because I'm quite sure you all already know a lot about training, else check out my other videos and like and subscribe if you want to know more about those steps. Once you're here, you really want to, I would recommend that you pip install -r requirements on text. This is these files. Run these, then you have all the required libraries installed for this tutorial. Once we got our file, so we'll use Pandas, which is, if you don't know, it's basically a tool that loads up CSVs. We'll load it up and then we'll have a data frame. Once we've got this, we pretty much this file here in our application. Then we'll select in good old machine learning fashion. We'll call this label survived, and we'll call the features, we'll call them X, big X from here on. Especially decision trees handle all kind of features pretty well. Be a bit careful if you're using other features. Convert the sex, which is here female, so the string female or the string male, we'll convert it to female, or 0 else if it's a male. As we can see, I shortly printed here the actual features for you. We can see it's just a lot of rows, so 850. And they'll contain the sex as 0 or 1, so 1 being female and 0 being male. And we do have the class. So what's the class? The class is the person traveling first class, second class, or third class. Usually you train test split your things. I did 80-20 here. Usually you would be using sklearn software to actually shuffle your data and get a nice split, and maybe have separate files for it and all these kind of fancy things, but just to keep it short. We'll then initialize a decision tree, which is this model we were talking about. We'll fit our data and we'll look at how good we are. So we're actually pretty decent given that we only use 2 features. So we got an accuracy of 76%, which is quite honestly for just 2 variables, this is pretty strong. We finally dump our model. So this file is probably what you want to change with your project, and here is your fancy machine learning models and all the feature transformation and the serious data science you're probably doing already. So once you got this, you want to store your weights such that you can later on load them into your API. But for the simple one, this is more than enough. Great, so we got through the model. This is now our actual server. So I put 2 things here into this class. Actually, this is more of the classifier itself. We'll throw it into a little bit of a class such that we can easily use it in the API. Down here, what we actually got is the server definition itself. And what is this? This is basically, so this is not very elegant, but it's simple for the tutorial. So what this is here, we'll actually call the FastAPI object. This is then stored here in the app, and we can then define our API like this. So let's first get into how do we actually make predictions with our predictor. I throw it in a very simple class. So this is just the object we're sending around. You can see it's very simple. It has the 2 features that we have. And what we want as a return type is a probability between 0 and 1. So what is the probability this person will survive? What you usually do is you load up your model. Be very careful if you have any kind of transformation like SCD scalars or label encodings or something. You also have to load them up here, and you have to apply them later here. So this is the actual function that does all the work. We can see here, I put some print statements. We'll later go step by step, but which step, what object looks like what. But basically, first you'll get in an object like this. So what this will actually be looking like is a bit like a Python dictionary, so to speak. And you can just access the key values and put them into an array. Be very careful that the order here is exactly like the order here, because if it's not, then, well, then your model doesn't know which features are the right features, and it's gonna be terrible. Anyway, you have to do a reshape, quite simple here with Numpy, just because it's just one object, it is a bit weird. I'm not sure if this is actually the best way, but I think for the tutorial this is absolutely okay. Once you got this, we'll actually call our classifier and do the actual prediction. So this is the same thing from sklearn as predict, but with predict probability you will not get 0 or 1. So if you just want a 0 or 1 answer, you could say predict like this. But we want predict probability because, yeah, gives us a bit more feedback and makes it a bit nicer, and you can, on the other side, show a bit more information. Because the probability object is not just a simple number, it's actually like some multi-dimensional array. In case you're working with multi-class classification, you may have several probabilities, so it's a probability of class 0, plus class 1, class 2, and so on. We just want to give back the probability of survival. So this is actually this number here. So the second number, what's the probability of 1 in the label? Great. This is actually all you need to do your machine learning prediction. We'll initialize here this survival predictor we just defined, and the API can use it now. Just to get you very shortly running on what the API is actually doing for you, I would like to show you now how it works. So this is the development command that you can use. If you installed it with the requirement.txt file, this is this package here that just runs the server for you. All in all, let's start it. What this will now show in the console is exactly where it's hosted, what errors, what is the request, and all these things. So let's test it for now. We have to go to port 8000 because we didn't configure anything else. In case you wanna configure anything else, you can simply do this by -- port on the startup command. So here, -- port, and then the number you want. As you can see here, this decorator object here is how you define. The root is basically if you just type the nothing. So the main entry point will be here. As we can see, this is exactly what I returned here, and this is just a reminder for you such that you know where to go. Now FastAPI has this really handy GUI for testing your API, which is will survive. This is the only thing we defined really, as we can see here. So this is a post request. So generally, if you have any internet related things, you want to pack them into a try catch, and quite cool here, raise a HTTP exception, which also implemented the FastAPI set. This is pretty meaningless because for 18 code is really just, it's like an April Fool's HTTP status code. Handle the errors properly. We will not do this because we want to be fast. How we can actually do now our prediction? So you can try here, try out, and you can say, hey, male from first class, and what is the probability of survival? 28%, not bad. What would be the survival rate of a female? 92%, so generally a bit better to be female on the Titanic, but women and children first was the mantra back then, so that it was to be expected. What I love about FastAPI, it gives you here also the curl command. Curl is like a console application, so you can now enter this into your terminal, and it will also let you test it from there in case you want to test any workloads or do several tests. It's just easy to copy paste. If you have like Postman or something else that you're fond of, just use it. No issue. I kind of like it because it works well here on the computer and good for video recordings. We got now our server, we defined an API, we have a machine learning model. What's next? Test is very important in case anyone changes this file. Let's say 3 months from now I come along and I'm like, this classifier is stupid, who will be using a decision tree like ever, and why are the hyperparameters so shitty, and I really want to change it. So I open this file here. I maybe have a new Python version installed, and then I dump this new file, which is a way better classifier and everything, but it's trained by a different sklearn version or a different Python version. Once I deploy it, I will get into trouble because our Docker file will have the wrong version or our server will have the wrong version, and it just won't load up. This is exactly why you want to use tests, just to assert that the program is working or the API is working in a way that you expect. You can do a lot more tests. I just want to highlight this very simple. What I really care about is that here in the test class that we load up the model correctly and that it sometimes returns once probabilities above 50% and that it sometimes returns probabilities below 50%. So to those of you that don't know what a unit test is, it's an entire branch of software engineering. Don't think too much about it. Really, it's just a way to assert that your programs work as expected. So in practice, you would be doing a lot more test cases and a lot more edge cases, especially because what if somebody sends you negative values? What if somebody sends here like female with a capital F, or you never really know. So testing is it's a lot of challenges that you have to address and you have to think outside the box here. But just to remind you, do this. In practice, I would not do this in the Docker container itself, as we'll now implement it. I would outsource it either to like some service like Travis, run it before you actually build the Docker container. But today we'll not do this, just to simplify the tutorial a little. We've already built an API in just under 20 minutes. This is perfect. But what do you do now if you want to actually deploy this? In practice, people use Docker, as I already mentioned. There are a lot of reasons for this. A big part is efficiency. A lot of it is you can actually automatically scale it with Kubernetes in case you need. I mean, you never know how many of these APIs you'll need. Maybe you need one in Africa, maybe you need one in South America and one in Europe. Maybe you need 5 in Europe and 1 in Asia. I don't know. Not getting too much into why and how you can use it in the future. I just want to highlight that you really should learn a bit about this technology and that it will simplify your life a lot, especially when deploying this application later on. To get really simple into Docker, for Docker you have several things. You have first you have an image. An image is basically like, can think of it as a freshly installed Linux application that has nothing on it. So usually what we load onto it is a different image, not the Linux one. So you can go to Docker Hub and you can look through all these images. It doesn't matter. They have databases, they have Python, they have like JavaScript, whatever servers, and everything that you can run pretty much on a cloud. We'll be using the FastAPI image today because, well, we're actually running a server UVcorn with FastAPI, so this image is perfect. Here, if you did not run this with Python 3.7, please adapt this number to be the same number that you use to train your application with, then it should probably work. This is one thing that a Docker container has. The other thing is a so-called cmd command. This is here in this file implicit, just saying what you'll usually write is here cmd, and then this command that we just ran in the shell or in the console was this UVcorn main $:-reload. This is effectively already in the image configured, so you would be running this here at the end. You have to think this is like kind of implicit, right? UVcorn start, or I don't know what this command actually is, just like high level. We got this now. So once we've started up our new freshly installed Linux thing with UVcorn and FastAPI and Python 3.7 on it, what we can do is we change our working directory. Where do you want your application to land? All commands from now on will be relative to this folder, which is app. It's just the recommended folder for FastAPI. Next thing you have to do is you have to copy all the files that you will need in the Docker container. For us, this is the requirements of text, Python packages that we want to install. It is the test.py because you want to run the tests. It is the main.py because it holds our API, and it's the model itself. You want all of these things to be in the Docker container such that you can later on easily deploy them to the cloud, and it's pretty much as minimal as possible. As mentioned, the test is not really needed. You have to install the dependencies. I usually do it exactly after this step because if something fails here and you've already done these steps, it's not so useful in the caching process, and kind of build step by step. But you can also reshuffle these commands pretty much in any order and it would still work. Finally, you want to run the tests. So once you've installed your packages, your tests can actually succeed. This is actually almost already it, because so Docker has several things. So not to go too deep into it, there's Docker Hub, which is like a website. It's like GitHub, and Docker is more like Git. So just to make an analogy. And there's also Docker Compose. So Docker itself is not that useful. Where it really comes in handy is when you have like several containers and not just one. Today we'll just do one, but imagine you have also like 3 databases here, and it's somehow you have 3 Docker files and you somehow want to manage them together. You want to somehow them being aware of each other and each having their separate dependencies and, you know, their separate life, not too much connection. Of course, only the passwords and the secrets that the respective service needs. What you do now usually is there's Kubernetes, which is a whole different topic and not getting into it today. But what there is Docker Compose. So this is just what the Docker Compose file looks. This is just basic. Don't think too much about it. It's really just, hey, we're using this version of Docker Compose and there are old versions. Don't use them. Then you'll have a service tab, and below this you will actually define your application. So you can imagine here being like SQL and definition. Anyway. Today there is only one container, so it's not that useful, but I just wanted to get it done for completeness, because some of the cloud providers maybe want this one and not the other one, and yeah, just so that you also see how to do it. One really cool thing you can do is here restart and say always, so that means if somebody like malicious tests our API and sends it like negative numbers and it crashes, it would automatically restart also if you now test it. So what you generally would be doing with Docker, you would actually build an image. So building an image is the entire process of copying these files around and making the entire container, so to say. With Docker Compose, you can actually include this building process into the Docker Compose file. And what you have to give it is what Docker file. So imagine you have now several folders. You have here a new folder and you will call it, let's say SQL, right? Then you may have here the Docker file being in ./SQL/Docker file. So just in case you would have multiple containers, this is not the case here today. So this Docker file will relate to this Docker file here, which is called, well, Docker file. You may give it a different name, right? Context just means, in case you have several folders, you would need to specify this. Since our server is going to run on port 80, we just have to map basically the port from the outside world, from the multi-Docker container architecture to the inside Docker container architecture. Don't think too much about it. If you ever work with it, there will be reasons for this. So this is basically now already everything. What you can do now is Docker Compose --build, actually up. So Docker Compose up --build. What this will do is we'll take this file. It will look, hey, from top to bottom. Hey, I want to build this object thingy called API. Where do I find the definition? It's in this Docker file thingy here. What do I have to do? It will go step by step, so you can see here. So let's actually get step by step through what this does. So first is off, it loads this image we discussed the entire time. So it doesn't load it up from GitHub, it loads it up from a place called Docker Hub. But just a short notice, this is not a tutorial on Docker itself. What it then does is it changes its working directory. And imagine this freshly installed Linux instance. All it has installed is Python. It has this server Uvicorn and it has the FastAPI package installed. So where do you want to install your package? Everything from now on is relative to this path. As you see here, it's using cache. In my case, in your case, it may actually take some time. Then we copy our requirement text, we run our pip install, we do all the things. Here we can say, hey, we copy the model, and eventually we run the Python test thingy. If we would now change this, the test, maybe we could change once to fail, this would not succeed, and you would see here an error, and you would know, hey, I fucked up somewhere in the process. So this is exactly why we're using tests. Once you got all of this running, the server starts, and you can see now here it starts at the place where we configured it to be. So, this is basically localhost. Let's go there. And you can see, oh, great. Our thing is running, and well, this has been the tutorial. If you liked it, like and subscribe. You can test here the API. It's really a short tutorial. There's so much more we could discuss. If you want to discuss any of these things we talked about today, please leave a comment to ask. I can definitely point you to resources, and yeah, it was a pleasure.